Okay, good afternoon. So let us start today's lesson. This is the last session that I will talk about this exponent. This I will not take all the time of this session. You have already seen probably that I have uploaded a quiz. I want you to work on that quiz alone, okay? But then of course, that is not something that adds something to your grade, or if you do not do it, you will lose. But if you do not do it, then probably you will not be able to do the real test as well. So that is just for your own preparation. And that's very important, because in this Google form I get in statistics that how many people could solve which problem. So if I see that most of you are making a mistake in one of the problems, then it shows to me that probably students have some difficulty with that question. And I can actually present the question here, and then we can discuss why you have difficulties about that. Yes, and hopefully this is for me new. So if I have done everything right, you can only submit once. There is no time limit how much you want to think, but you need to respect the due date and time, which I think is next Sunday. I don't remember. There are many quizzes going on for different classes.
So I really. Friday.
Is Friday? Ah, okay, it's Friday. This Friday?
Yes.
Okay, there are only 5 questions. So in principle, it shouldn't take you that much time so that you can do it. It is no problem if you want to talk together, but because usually I see that when you talk together, one of you solve the problems and the other one is just following. This is not good. You can think about the problem first yourself, and then if you really don't understand, you can ask your friend. Because there are 2 things about it. If you can explain to your friend, you understand better yourself. And yeah. So might be if you ask your friend, you get an opportunity to be taught by someone else except me. So this is some kind of a skill I think you need to learn. When you know something, you should be able to explain someone else what is going on. So that's also a good skill that you can develop. But do not start solving the problem using exactly from the beginning together. So you take your pen and paper, try to solve your problem, your friend will solve his or her own way, and then you can compare. Okay, so that's not important. So if some of you can solve the problem and then everyone can copy and paste that one, which is not useful at all. Anyway, so even if you get 0 points in this quiz, it will not have any effect to your grade. If you get all the points, it will not have any effect on your grades. Yes?
Have you already sent the quiz?
Yes, it is already. So no, this is another question. Let me just say this once for all. Every time that I teach, in the night, I will update what I have done and what I expect you to do under my recommendations. Have you seen that?
Yes.
Yes? So every time, probably not immediately, but before going to sleep that night, I will update what I have done and what I recommend you to do. I expect you to follow those instructions. If you do not follow, the responsibility is all yours, and it is now being recorded. So you cannot say that I didn't say that. So I told you that. You really need to follow me, okay? I am not probably have time to follow you one by one. Okay? So, and I told you that if you are not notified, please make sure somehow that you will be notified when I post something. Might be notifications, you say it's disturbing, but that's up to you. At least you need to develop this habit to regularly check the Google Classroom. So there are many things that are on Google Classroom nowadays, recommendations and everything. But from the next session that I will start algebra, I will follow exactly the book. I immediately give you the links, which parts you need to study and which exercises you have to solve. Okay? And please do it. Otherwise, this course will be heavy for you at the end. Any questions now? So a quiz is, everyone knows where to find the quiz? And so the deadline is Friday, I think, at 12 o'clock, yes?
Can you write the code for your classroom? Because I use another Google account now, and I was logged in there for another one.
So why are you talking it right now after all many sessions? So it means that you haven't checked that at all, yes? Yeah, you can get it from your friends.
Okay.
Yes, or at the end of this session. Okay, so everyone knows that you have to check the Google Classroom yourself. Yes? So if you have an exam, I will announce it there. If you do not see it, and when you face the exam, you cannot just complain, I didn't know about the exam. I will write everything there, yes? Good. So let us continue solving some problems. I think that's also good to know about these things before finishing this topic. So one question for you is, what do you think if I have a square root, for example, of another root? So can I write this as one single surd? So for example, let me just start with the cubic root, and then I have the fifth root of 2. So below this, the third root of the fifth root of 2. Yes? So I want to write this. How many surds are involved in this notation? 2 of them. One of them is the third root and the other one is the fifth root. Do you think I can write this as one single surd sign? Give me a number which is equal to this, yes?
The third root
Yes?
of 2 to the power of 1 over 5.
Yes, exactly. So what you are saying is that if you want to translate this, you would translate it in this way. You would say, let me just translate this one, which means the third root of this number, yes? And then, if I ask you what this symbol, what is another form for this symbol, you will say 2 to the power of 1 over 5, and then to the power of 1 over 3. Yes? So whenever you want to discover a rule about these surd symbols, so what you need to do, you need to switch back to your familiar notation. Our familiar notation is the exponential notation. And then because we have some rules there, then you can use those rules. But it is important to translate it back to the language of surds. That would be actually ideal. So, which rule can I use here? Do you remember? If I have an exponent and I raise it to another exponent again, so then we know what to do. We write the base and we multiply these two exponents. So this is one of the rules that you should probably know by heart by now after all these sessions working on exponents. Yes? So here, this 2 is playing the role of this A, this 1/5 is playing the role of M, and this 1/3 is playing the role of that N. So what can I write if I want to? I write 2 here, and then I will multiply 1 over 5 by 1 over 3. Yes? And now if I ask you, is there a better way to write this? Everyone knows this is a very trivial question. So what would be this power? 1 over 50. Now can I translate this back into the language of surds?
Yes.
So it would be the 15th root of 2. So that was a very nice thing to learn. So you see I have a third root, and then I have a fifth root below it. I can immediately combine this and write the 15th root of 2. And I think now you can understand what is the rule actually. If I ask you about this, I have the mth root of the nth root of A. Now, without doing this process, can you immediately guess what the answer will be? So, yes?
M times n root.
Yes, exactly. Because what we did here, we just multiplied these two, yes? So I got the 15th root. So here, the formula, of course I don't want you to memorize that. If someone asks you why this is correct, you should be able to explain. But then, of course, after explaining and understanding, you should be able to quickly use that if you want to, okay? So if I have more roots. For example, what happens in this case? If I have square root of the third root of the fifth root of 7. So what can I write here? I think you can immediately answer that without going through this process. If you want to, if I want to really go through the process, what should I do? I should write, this is the second root of this number. Yes, but this, so let me write it step by step. I don't want you to do these steps. I want you to understand, of course, but do it quickly. And then if I ask you what is this one, you would say this is a second root here. This would be a third root, and that would be the fifth root of 7. And this becomes, again, 7 to the power of 1 over 5 to the power of 1 over 3 to the power of 1 over 2. And then you multiply these powers, so it becomes 5 times 3 times 2, which is 30. And then you translate it to this language. So it becomes the 30th root of 7. But you really don't need to do this process after understanding. You immediately just multiply these numbers and write them simple. So if you want to do it, immediately you write it as this root 2 times 3 times 5, 7. And then you can immediately write that this is the 30th root of 7. But if someone asks you where this rule is coming from, you should be able to explain that. Okay? So, this is something that I want you to know. Another thing, let me just remind you. You remember I talked about this. If I ask you what is the second root of 100, all of you can answer. This is just what, 10. So some numbers are complete squares. They are complete so that you can just simplify and take the surd sign away. But if I ask you the same thing for 27, for example, but 27 is not a complete square so that I can get rid of the surd sign. Either I should leave it like this. If you put this in the calculator, that number that you get in the display is not the exact value. It's just an approximation to square root of 27. But if you want to algebraically simplify that, what can I do? I can write this 3 times 9. Why is that good? Because 9 is now a complete square. And then do you remember I have a formula that I can write this multiplied by 9. Yes? Now if I ask you what this number is, you can answer exactly 3. But this is not an exact, I keep it. So this becomes 3 times this number. Okay? So you need to learn this trick. Even though this is also not complete. So this is probably involving a square root sign again. This is also involving the square root sign. But this one, for our brain, is easier because this is dealing with the square root of 3, but this is dealing with the square root of 27, which is a larger number. Anyway, so you need to learn that. But this we discussed before. Today, I want you to learn the other way around. Of course, sometimes this is given, and you should be able to write something like this for it. Okay? For example, in this case, if I ask you can you write this as one single surd? So what's the meaning here? So here, square root of 2 is a number. I multiply it by 2, it becomes a new number. And then from the whole number that you see here, I am taking another square root. And if I ask you how many surd signs are involved, you say 2 of them. But my question is that I want to write this with just one single surd sign involved. I'm not saying it should be a square root. No, but I just want to have one single surd sign. If this 2 was not there, you could answer me. If I ask you this, we just discussed about that. Can you do it immediately?
Yes.
What is that?
To the root of 4.
Fourth root of 2, yes? Fourth root of 2. Why 4? Because this is not written, it means it is 2. This is not written, it is 2. So I multiply them, it becomes 4. And that's exactly this rule that I wrote here for. Now that I have this 2, this is a little bit of an obstacle here. Yes?
You multiply 2 by itself, so you can move that number 4 to the third in the
Exactly. Thank you. So the idea is the opposite way around. So here I asked you what is 27, square root of 27. You answered 3 times square root of 3. This was in this direction. But now I need to learn how to go back in this direction. Okay? To make it as 1 third without the coefficient, without this factor here. So, but the rule is to do what? So can you tell me what is the rule? For example, if I have 5 here, if I have the third root here, and I have 2, can you tell me how should I move this inside the third? So this is a factor. I want to move it inside the third. So you need to imagine of a number so that after being simplified, 5 goes out. Yes?
5 to the power of 3
Times
2.
times 2, exactly. Is that understandable for everyone? Let me just try. Let me tell you why this is correct. If I ask you what is the right hand side, you can write the third root of 5 to the power of 3 times 2, but you can write the third root of 5 to the power of 3 times the third root of 2. But if I ask you what is this expression is just simplified. Is that understandable? Because it is asking you, give me a number so that when I raise it to power 3, it becomes 5 to the power of 3. It's clearly 5, because if you raise 5 to power 3, it becomes 5 to power 3. And then you have the third root of 2. So the rule of thumb is this. If I have a number outside a third sign with the n here, and then I have b. If I want to, sometimes I need, like this problem, sometimes I need to move this back inside. What is the rule? I need to raise this one to this power, multiply it by the number below the third sign, and put the third sign as before. It's extremely important rule. Please write it somewhere down that you know and use it. Of course, I need to be careful about the signs, yes? If this is even, this is negative, don't take the negative with you. Just take the number itself with you. So, for example, let me just write 2 numbers. If I have, let me just do it here. Or let me just write it here. So 3, I want to keep the numbers small so that you are not distracted by the numbers. So let me write here 2. And let me write 3. And let me write 3 here. I want to move 2 inside. What is the answer? Of course, you might say, why should I move 2 inside? Some problems need to do this. For example, I will come back to this. I want to move this inside. If I want to move this inside, what is the rule? I need to write the third root. I raise this to this power, so this becomes 2 to the third, and then multiply it by this number. But of course, I need to calculate this one as well. So 2 to the 3 is 8. 8 times 3 is 24. So then it becomes the third root of 24. So you need to know both directions. Sometimes this is given to you most of the time. You need to make it simpler. So you need to know how to go back. And sometimes this coefficient, this factor, is before a third sign. You insist to put it inside. If you want to put this factor inside, you need to raise this number to this power and then multiply it by the number below the third sign. Is that understandable why or not?
Yes.
Yes? Everyone?
Yes.
Yes? Okay. So now, what happens if I have, of course, a negative number, then you have to be really careful. If it is negative, and this is, if this is negative, it's better to keep the negative sign outside. So if I want to do this, if this is even, I can do it both ways. I can keep negative sign outside, or I can move it inside. That's up to me. Okay? So for example, I can keep the negative sign here, then only take 2 and raise it to power 3 and multiply it by 3. So it becomes negative third root of 24. Or if you want to, you can take minus 2 with you inside. So this becomes minus 2 to the power of 3 times 3. But then it becomes the third root of negative 24. But these two numbers are exactly the same if you remember. When this is odd, you can put the negative sign here or outside, it doesn't matter, they are the same numbers. But when it is even, you have to be careful. You are not allowed to take the negative with you inside. So if there is a negative, you have to leave it behind. So for example, if I have this scenario, I am not allowed to take negative with me inside, because if the negative, it's a negative number, then it is not allowed to have a negative under the even power, even root, yes? So I keep the negative sign here, then I have 4, then 2 to the power of 4 multiplied by 3. I have to raise this to this number and multiply it by the number below. So it becomes minus the 4th root, 2 to the power of 4 is 16, times 3 is 48. This is the only way when this number is even. But when this number is odd and you have a negative sign behind, depending on the situation, on the problem that you are working on, sometimes it might be good if I put the negative sign outside, or if I want to, I can take it with me to the under the third sign. Yes? All of this is now relevant to this problem, as Ali actually told very nicely before even I explained this. So what we do, we keep this bigger one, and then I move these two below the square root. How? I need to copy and paste this square root, 2 to the power of 2, this is not written, it is 2, and then you multiply it by these 2. Okay, I have two surd signs. 2 to the power of 2 is 4 times 2 is 8. But then I can write this as one single surd using this rule. So what can I write now? Yes? 4th root of 8. So you see, if I don't tell you these rules, then calculating these things would be a little bit hard. Okay? But of course, if you forget everything, you have to start everything from the scratch. Okay, so let us, for example, do this thing, assuming that you don't know these rules, because these are not given in the book. But if you use them, that I would be much more happy. So it means that you are learning. But if this question is given to you in the book, it doesn't mean that you cannot solve it. Actually, you can. But you need to start everything from scratch, using only this rule. So how can I use only the rules of powers? So can you tell me how should I do that? Assume that you don't know these methods and still you want to solve this. How should I do that? I don't know. So for example, there are different ways to do it. For example, let us copy and paste this square root sign for the time being. And instead of this, what can I write in the exponential form? This is 2 to the power of half. And then I have another 2 here being multiplied. Yes? But then let me just again copy and paste this surd sign for the time being. But I already have a rule for these kind of things, yes? So the power here is not written, so it is 1. And the bases are the same, so I write the base and I add the exponents. So it becomes 1 plus 1/2. Agree? And then what happens? What is 1 plus 1/2? Can you do it in your head? In fraction form?
3 halves.
3 halves, yes. So it becomes 2 to the power of 3 halves. But what can I do now? I have a square root again. So this becomes 3 to the power of, 3 halves to the power of 1/2. Yes? And then I have, this is another rule that you have to know. This is a have to. So this way of doing is exactly in the book. Here now you have two options. If you want to use this method, that's okay. Otherwise, you have to be able to do it in that way. So the answer becomes 2 to the power of this one, another power. According to this rule, I have to multiply them. So what's the multiplication? 3 over 4. But then you need to be able to write this as a surd sign. So what should I do? I would write it as 2 over 1. I should write it as 2 over 3 to the power 3 to the power of 1/4. But 2 to the power of 3 is 8 to the power of 1/4. And then this is the 4th root of 8. So but you see that was much quicker, that method, if you want to do. But anyway, if you write this, some way I would say this is better, because it shows that you really understand what's going on. Here, when you are doing it, doesn't mean that you don't understand. You need to understand it once and then do it quickly afterwards. Yes?
Could you please repeat the first part?
Here,
Yes.
I just copied and paste this bigger one. Instead of 2, I just again copied and paste that 2, but instead of this part, I have written 2 to the power of 1/2. And then I have another rule of powers, which probably is very famous for you now. It becomes a to the power of m plus n. So here, this 2 is playing the role of that a, 1 is playing the role of m, and 1/2 is playing the role of n. So I have used that rule. So I have written a to the power of m plus n, which is 1 plus 1/2. Is that it?
Yeah. Thank you.
You're welcome. Any questions here? Okay. Of course, these playing around with these surd signs might be interesting for the people who are actually liking these kinds of problems. But let me give you some examples. Okay. So, for example, can you write this as one surd? So the second root of 2, the second root of 2, second root of 2. Okay, so I just want to see how many of you can make it calculated. Not calculating, I want you to write this as one single surd. Okay, let me just pause the recording. Yes, please.
When you take in 2 into the other root, why is it 2 to the power of 1 and not 2 to the power of 2?
No, I didn't take anything to here.
Huh?
I am just writing, I am solving in a different way. I am not moving this inside.
Okay.
That method was moving 2 inside, which is here, but I am telling you that if you forget these rules, you still should be able to solve this problem, but a little bit longer.
Okay.
Yes. Okay, I pause the video for 2 or 3 minutes. I think should be enough. It's not hard. Okay. So, do you have any answer for this? Do you have any answer for this? Yes?
The root of 128.
128 is right, but not the root.
What?
128 is a good number, but you said a root?
Yeah.
So what's the number on top of the root?
Two, yeah, but it's...
No, it's not 2. Yes, Tim?
And
No, you are close.
2.
8. 2 times 2 times 2 is 8, not 6.
Yeah.
Yes? So that's right. It's the 6th root of 128. Let us see how. I want to use the method that I just actually told you. So what we do, we take this one and move it inside here. So be careful not to get confused, okay? So I don't know how to explain this. So what I do, I actually copy and paste this one. I do not have anything to do with this yet. Okay? I copy and paste this one. And I do the same thing here. But because I am trying to move this below the first surd sign, the goal is to raise it to this power and multiply it here. But 2 to the power of 2 multiplied by 2. Let me just write it patiently. In the future, if you want to read, at least you understand what's going on. So what I have done, I want to move this 2 below this surd sign. The rule is clear. I have to raise it to this power. This is not written, so it is 2. And I put it there. Yes?
Yes.
But don't leave it like this, because no one leaves this number like this. There is a better way of this number. 2 to the power of 2 is 4. 4 times 2 is 8. So what I do, I have this, 8 square root of 2. please let me know if you don't understand these two steps. Understandable? Yes?
Is it better to write 8 or 2 to the power of 3?
Might be you are right, 2 to the power of 3 is good. But this number was so small that I did it. It depends. If the number is big, I cannot do it in my head. I probably leave it like that. But you are right. And now here, what I have to do, I copy and paste the first 2 surds. Then my goal is to move this below this one. But the rule is what? I copy and paste the third surd. I have to raise 8 to power 2 and multiply it by 2. But again, this number is not that big, so let me just copy and paste these 3 surds. 8 to the power of 2 is 8 times 2 is 128, as your friend said, but might be he just miscalculated here. So I have 3 second roots consecutively, but we learned the rule. We put this 1 over 28 below, and this number which is not written is 2. This number is also 2, this number is also 2. I am supposed to multiply them because of the rule that I started today with. So then this becomes 2 times 2, 4 times 2, 8. So if I want to write this combination as one single surd sign, that would be the 8th root of 128. Yes? Okay, let us go to the other problem. Here I haven't asked you to write it as this one single surd. I have asked you to write it as an exponential. Exponential means something with a base and an exponent. But I have also emphasized that make the base to be 2. Of course, that is not very strange because 2 is involved here. I don't know. I myself prefer to use these methods. If you want to, you can start from scratch everything. So let us just try to use this method. So what I do, so let me just write it in one line so you can see it properly. So here, may you tell me now, can you tell me what is the starting point? If you want to do the same thing here. So I take which one? I want to take this 2, which is here, and move it inside. That's my goal, yes?
I have a question. Can you go over the first step in here?
Here?
Yeah.
That's the first step. Let me just do it here.
Okay.
They are exactly the same thing. So here so this was the rule. Let me tell you again. If I have a number here, and I have a surd sign here with some number on top and a number below, we just learned that if I want to move this inside, we were convinced the rule is this. You copy and paste the surd sign with that number, but you raise this to this power, which becomes an, and then multiply it by b. This is the rule that I am using. Did I answer your question?
Yes.
So that's the same thing. Here, forget about the complexity here. I just want to move this 2 inside the first surd sign. This number is not written, it is 2. If you can do it in your head, it is much better. But of course, might be you want to refer to your notes later. So let me just write every step. You really don't need to write all these steps. So I copy and paste the surd sign with root 3. And then I copy and paste this one. And then I write it as 2 to the power of 2 multiplied by 2. Then I have the 5th root of 2 again. I want to make sure that every one of you understands the first step. Yes?
Isn't it easier if you put 2 to the power of 2 times 2 to 2 to the power of 3? Isn't that easier when you
Yes.
go to the next step?
Yes, of course. I'm telling you that please try not to write all these messy details. But make sure that you understand it, do it in your head. So I myself it's much better to write it to the power of 3. Here, I don't want to write it as 8. Because then I will have problems, yes? Because then I have to raise 8 to power 5, which is hard for my brain, yes? So what I do, as you said, let me now clean this. Yes, let me clean this and write 2 to the power of 3. Yes? 2 to power 2 times 2. But now, what should I do? I need to consider this number. I want to write the details here and move it below this one. How should I do that? So this means that I have two copy pastes I have to do. The third root, the second root. Okay, now I want to write the fifth root, but my goal is to move it inside. What is the rule? The number that I want to move, in this case this one, should be raised to the power here and then multiplied by the 2 inside. Yes, is that rule understandable? So whenever you want to move a number inside, you have to raise it to that power. The number that I am moving it right now is this exponent. So when I raise it to power 5, I have to write it in that way. But then, so let me just copy and paste everything here. So the third root, the second root, of course you don't really need to write all these things. I really want you to be able to be quick in these things. But what can I write for this? You can do it in your head. What is the whole combination here? Can you just say me? 2 to the power of 3, again to the power of 5, then multiplied by 2, yes? What's your name?
16.
What's
Marcus.
your Marcus. 2 to the power of 16, yes? Because this and that are supposed to be multiplied and then one more is added. So this becomes 2 to the power of 16, yes? And then of course, 2 to the power of 16 is a big number, so let me just keep it like that. But you know that I have consecutive surd signs, the rule we learn. I have to multiply these numbers. This number is 3, this number is not written, is 2, so it is 6, and then times 5 is 30. Do you remember, I also told you last time that this power and that number can be simplified. Yes? So what can I do? Simplified by which number? 2. So it becomes 2 to the power of 8, this becomes 15. But because I have expressed to write as an exponential, even though this is correct, but you shouldn't stop here. You have to show it as an exponential. So what should I write?
2 to the power 8 over 15.
15, exactly. So that would be the final answer. How many of you got this final answer exactly? Okay, so not that many. If you don't have any, if you have questions, please let me know. And congratulations for the people who actually did. So, yeah, these are not hard, but you need to work with them so that you can actually, you improve your skills. Because I want to finish everything about exponents this session, so let me move to another thing. Let me ask you one question here. If I give you this, 2 square root of 3 plus 5 square root of 3, if I ask you to simplify this as much as possible, but exactly, do you have something to say here? 2 square root of 3 plus 5 square root of 3. Yes?
We could start by moving the 2 and 5 into the third first.
But that will not help.
That will not help.
So let me, if you want to do that, I move 2 inside, it becomes 4 times 3, 12. Yes? 2 to the power of 2, 4 times 3 is 12. That is correct, I'm not saying that's wrong. But then the other one becomes 5 to the power of 2, 25 times 3, 75. And then I have to add them. So if you write this one is equal to this, definitely you are 100% correct, yes? But this is not simpler. You have an expression with 2 terms, you still have an expression with 2 terms, even though they are the same. Yes?
We could treat square root of 3 as a variable and just move add the 5 and 2.
Yeah, exactly. I have one, assume that the square root of 3 is a box or something, yes? You have 2 boxes, 3 boxes added to that. So how many boxes you have? So I have 2 boxes, 5 boxes is added to this, so how many boxes do I have? 7 boxes. So that's just the addition. So if you get this one, you get 7 square root of 3. I want you to understand. So actually, you actually made a good example. So you said that we can consider this as a variable. If I ask you, what is this? 2x plus 5x, probably you could answer immediately that this is 7x. But I want you to understand why we change the question a little bit, it becomes a little bit harder to answer. So this is very, very important. For example, if this I want you to increase, you know, this skill you need to be able to improve. So for example, if I ask you, what can you write in front of this? I don't know. So even sine x probably you don't know. So I'm just making something out of my mind. Okay, so what can I write in front of this guy? Something. If I ask you to, yes?
12.
12 of that thing, yes? Who cares? This is whatever it is. But this is exactly the same thing. Yes? Even if I don't know anything about that thing. I have 5 times of that plus 7 times of that. So in total it becomes 12 of this. This is for sure, yes? Even if I don't understand the details, but I don't need to understand the details to write this equality. Yes? Whatever it is, this is the same thing. I have 5 of them here, I have 7 of them here. In total I have 12 of them. Is that understandable? So try to understand this. So it doesn't matter if this box is a square root of 3, if this box is x, if that box is so complicated, all of them are the same thing. Yes? Now, this is I want you to learn because this would be later important. So for example, can you answer this something here? So I have 5 third root of 2 plus 7 third root of 2 plus third root of 2 minus 6 third root of 2. Can I write something in front of it? Simplified version of this expression. Yes?
8 third root of 2.
8. Yes, why? Because I have 5 and if this is the same package repeating itself. I have 5 of them, I have more, 7 more. So far I have 12 of these objects. 1 more is added. Yes, so it becomes 6. It becomes 13. But 6 of them are gone now. How many is left? 7. So it becomes 7 third root of 2. Okay, is that understandable? But sometimes the problem might be a little bit more interesting. Right, so let me find an example here for you. I'm a little bit tired, I cannot construct examples myself. Okay, so how do you... This is actually a little bit exaggeration. This is a little bit hard. So let me make myself something and then we go to harder ones together. So for example, if I ask you to simplify square root of 8 plus square root of 18. Okay? So then this becomes a little bit tricky. Can I simplify this in this form? No. Because a square root of 8 is not the same package of a square root of 18. Yes? It seems that I have a pen and a notebook. I want to add them. I cannot say that I have 2 pens. I cannot say that I have 2 notebooks. I have 1 notebook and 1 pen. Yes? Unless there is something going on that I can change them into one form. And that is the rule that you learn. A square root of 8 can be simplified by pulling the numbers out from 8. How can I write it here? I can write 4 times 2, agree? Yes? And for 18, I can write 9 times 2. Yes? But now, here I can write the square root of 4 times the square root of 2. Plus, for this one I can write square root of 9 square root of 2. Agree? But the square root of 4 is 2. Square root of 9 is 3. This is not z, this is 2. But now, can I simplify them?
Yes.
Yes. Because I have 2 of one package plus 3 more of the same package. Square root of 2 is the same thing. 2 of them plus 3 of them, which is? So this calculation becomes very, very important when you go to higher level calculation. So you see a square root of 8 plus a square root of 18 is 5 times the square root of 2. If you want to, you can move it inside again, but I prefer not to because I want to keep the number below the surd sign as small as possible. Yes? Yes. So if I want to write it as without any number, can you tell me what should I write? If I want to move this 5 inside.
50 square root.
A square root of 50, because 5 goes to power 2 becomes 25, and you multiply it by 2 becomes 50. The square root of, so this is very interesting, by the way. You see, if I add a square root of 8 plus a square root of 18, it becomes suddenly a square root of 50. It was not it was not very clear in the beginning, yes? Because a square root of 8 asks you about a number so that you multiply it by itself, it becomes 8. This asks you about a number that you multiplied by itself becomes 18, and if you add these two numbers, it becomes a number that if you multiply it by itself, it becomes 50. So it is very interesting. It was not possible to discover it without calculations. Is that understandable? Okay. So, but I prefer not to write it. By the way, you see that this rule is not working. If you think that you can add, this is a wrong impression. Because 8 plus 18 is 26, but you see the correct answer is a square root of 50, not a square root of 26. Okay. So is that clear here? So let me, I don't know, solve this problem. Yeah, they immediately increase the level, so let us see how, okay. So let me start from here. Let us do this together. So I want to simplify this expression. The third root of 54 minus 2 third root of 16 plus the third root of 128 minus 3 third root of 686. And if you don't mind, let me also, yeah, that's good. I want to teach you how to do it, because this is not as simple as before. So you need to learn how to factorize these things. If the numbers are big, so might be you need another method to solve the problem. Of course, the idea is the same. I want to pull out as much as possible. But if the numbers are big, might be I cannot do that. What I need to do, I want to teach you a systematic way of doing it. If so for example, for 16, I really don't need to do that because it is a small. But let me start from here. What I do, I factorize them. Do you remember this method of factorization I told you? So I need to put prime numbers on the right-hand side, so that this number on the left is divisible by that prime number, and continue this process. You always end up with 1, and then that's the end of the process. Okay? So I put 2 here, for example. 2 is prime, remember. When I divide it becomes 27. A prime number is 3, 9, 3, and that's 3, and 3, 1. So 54 is 2 times 3 to the power of 3. Yes? This you need to remember. We put it in a box. Then I go to the second number, which is 16. Yeah, please listen to this. This is very important. Divide by 2, 8. Divide by 2, 4. Divide by 2, 2. Divide by 2, 1. So 16, as of course you know, is 2 to the power of 4. If you already have it in your head, just skip this part. You just do it in your head. Okay, let us go to 128. Do you have 128 in your mind?
2 to the power of 7.
2 to the power of 7, thank you. So I can skip this one, because that is something I have it in my memory. If you have it, you just use it. Okay, so 100, so I will skip that one. 128 is 2 to the power of 7. But might be this a little bit hard. Again, let us do that. 668 divided by 2, for example. I divide this 343.
Yeah.
And then 343 is not prime number. I don't think it's a prime number. Is it 7? And then it becomes 49. And then again 7, 7, 7, 1. Yes? So anyway, this 686 is 2 times 7 to the power of 3. Yes? Now, the important thing is this one. Question mark is equal to. Instead of 54, patiently do that. So instead of 54, I write the third root of 54 is 2 times 3 to the power of 3. I go to the next number, minus 2 times the third root of 16, but 16 is this number. And then I go to the next one. You already told me this is the 2 to the power of 7. And then yes? Now we want to simplify this expression. I don't think you have any problems with doing that. So forget about these big numbers. Here, is there something that I can pull out? What is that? This 3 has the same power that I have the root here. So this 3 will go out. So then what happens? It becomes 3, the third root of 2. Is that understandable? If you don't understand, do it in the other way around in your head. What was the rule? I need to raise this to this power and multiply it by 2. I get exactly the same expression. So what can I do for the next one? What can I do for the next one? 2 to the power of, yes?
2 to the power of 4 is the same as 2 times to the power of...
Please close that. Yes?
So
Again?
you can pull out
2.
2, yeah.
Yes, exactly. So what you are saying is that instead of this, you write 2 to the power of 3 times 2. But then this power of 3 and this are the same. So I pull a 2 out. But there is also another 2 here. So it becomes how much? Minus 4 third root of 2. Yes? And then what happens here? For 7, what can I write? 2 to the power of 7 is 2 to the power of... I want to make 2 to the power of 3 times 2. Yes? Because I want to make this power which is exactly equal to this transparent. Of course, you can write it like this. You can write 2 to the power of 3 times 2 to the power of 3 times 2. Because I want to produce as many 3's as possible so that I can pull the number out. It doesn't matter if you write it in this way or in a more compact way. If this is easier for you, let me just concentrate here. So instead of 2 to the power of 7, you imagine this. But this 3 and this 3 are the same. So 1, 2 goes out. And another one, because of this, goes out. You already have a 2. Another 2 goes out, so it becomes 4. So it becomes 4 third root of 2. Okay, can you tell me what happens here? What happens? 7 goes out, and there is a 3 here, so it becomes minus 21 third root of 2. Now the problem is simple. Because minus 4 the third root and positive 4 the third root are gone. I have 3 of them, minus 21 of them. So it becomes minus 18 of them. Yes?